Okay, we are going to go over the review for your circles test for geometry. On your important info section for 9.3, there's a review of the circles equation. I know it's a little bit blurry on my video, so I'm just going to rewrite that equation right next to this. Okay, it says where HK is the center and R is the radius. Notice how in the formula it's a minus H and a minus K in the formula. If we look at our example down here, we have a center point at 3, 1, and we have a radius equal to 4. Okay, so in our formula, we take these coordinates and we plug them in. The 3 is the H and the 1 is the K. So our equation would be x minus 3 squared plus y minus 1 squared is equal to 4 squared. We would take one more step with that, and we would go ahead and we would square the 4 to get 16. Okay, so that would be our final equation. Notice how in this example, the center point had two positive coordinates, a 3 and a 1. If we did another example where our center, let's say, was -4 and +5, and our radius was equal to 6, we would take that negative and need to be sure that we put that in our equation. So our equation says x minus h. This is our h value, so we would have to write x minus -4 squared plus our k value is 5, so y minus 5 squared is equal to r squared, so 6 squared. When you have minus a negative, that is the same as saying plus a positive, so that changes. So our equation would then be x plus 4 and y minus 5, and we'd have a 36 here. So see how if you have a negative value in your for your center point, you're going to have a plus sign in your equation. Now keep that in mind as we do our practice problems. Okay, we've got a few practice problems here to do for this section. Right, so given the following equation, what are the coordinates of the center point and the radius of the circle? So we're going to keep our equation in mind that we just talked about. We know that this is r squared. Our equation says x minus h squared plus y minus k squared is equal to r squared. So in this problem, I can see that the -2 is the same place as the minus h. So when I write my center point, I'm going to have a 2 for my x value. And then when I look at my k, I see I have minus k, but it says plus 1. That tells me since this sign is a plus, that I need to make my y value negative. Okay. Then for my radius, if r squared is equal to 25, then I would just take the square root of that to get my r value. So my r is going to be 5. Okay, on the next one, if I have x minus h squared plus y minus k squared is equal to r squared, I see how I have plus 1 in the same spot as my minus h. So since the sign is opposite, that tells me I need a negative for my x coordinate. So it's going to be -1. I don't have anything subtracted from my y value or added to my y value. So that means I have a 0 for my y. Okay, so that's my center. And then r squared is equal to 8. So r would be the square root of 8. You can simplify that to 2 times the square root of 2. Or you could get a decimal approximation for that as well. If you did that on your calculator, see, you just type in the square root of 8 on your calculator, you get 2 radical 2. You can change it to a decimal depending on which type of calculator you have. It's 2.83 if we round, so we'll approximate 2.83. What is the equation for the given circle? So we have to look at our graph and decide where the center is for our circle. This circle, if I draw a line like this to cut it in half, and I draw a line like this to cut it in half, I can see that my center is at 0, 0. So if my center is at 0, 0, I just need to figure out my radius now. So my radius, remember, goes from your center to a point that's on the circle. The easiest way to count that is going to be along the X or the Y axis. If I count here, I can see that this is 1, 2, 3. So my R is 3. If I chose to count on my Y axis, it would have been the same thing. R is 3. So now when we write our equation of the circle, we're going to have X squared, because I don't have to subtract anything from it because I'm at 0. Plus y squared, again, I don't have to subtract anything because I'm at 0, is equal to r squared. R squared is going to be 9, because if I do 3 times 3, that gives me 9. All right, for my next one, for number 4, we need to see where our center point for our circle is. So we want to cut it in half. So I draw a vertical line and a horizontal line to see where the center of my circle is. The coordinates for this would be +1, -2. So if my center is at +1, -2, those are telling me my h and my k values. To get my radius, I'm going to find out the distance from the center to a point on the circle. That distance is 2. I'm going to use those values to plug it into my equation. X minus 1 squared plus y minus -2 squared is equal to 2 squared. This 2 comes from the radius. If you wanted to skip this step and just go straight to writing a plus sign there, that is totally fine. You can skip that step. And we get x minus 1 squared plus y plus 2 squared is equal to 4. All right, the next one. The equation of the circle is given below, but there's one piece of information missing. The diameter of the circle is 12. What value goes into the blank? So we know our blank here is supposed to be r squared. This says diameter of the circle is 12. Remember that diameter means all the way across the circle through the center point. So if we know that all the way across the circle is equal to 12, the radius is going to be half of that, which is 6. So in our blank, we're going to have to do 6 squared. We're going to have 36 for our blank. Okay. For number 6, the equation of the circle is given below. One piece of information is missing. This one says the radius of the circle is 4. So r is 4. We know the blank is r squared. So 4 squared is 16. So 16 would go in our blank. Okay. The next section that you guys covered is 10.4. So we'll go over that next. Okay, we have important information at the top showing the formulas that we need. We have the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So remember that inscribed angle means that our vertex is on the circle. So these are all examples of inscribed angles. The vertex is on the circle. Okay, it says the inscribed angle is 1/2 its intercepted arc. Intercepted arc is the arc that that angle cuts into. So that's an intercepted arc, that's an intercepted arc, and that's an intercepted arc. Okay, so that angle is half the arc. This other important information says the measure of an angle formed by a tangent and a chord is 1/2 the measure of its intercepted arc. So if you remember, tangent means a line that only touches the circle at one point and it's outside of the circle. So this AB is our tangent. Okay, a chord goes through the circle and ends on the circle. So BD is our chord. So the measure of the angle formed by the tangent and the chord is 1/2 the measure of the intercepted arc. So this is showing that ABD, this angle right here, is 1/2 of the intercepted arc. And the intercepted arc in this case is from here to here. Okay, this is actually should not have a C here. It was out of your book because it's a minor arc. So we should not have 3 letters to name that arc. We only need 2, arc BD. Okay, the other important information that's in here, it says 2 inscribed angles that intersect the same arc are congruent. So we are looking at this inscribed angle here, and that it intersects arc RU. And then we are also looking at another inscribed angle, RSU. It also intersects RU. So it's saying that if the angles, the inscribed angles, intersect the same arc, then the angles are the same. Okay, the next corollary says an angle inscribed in the semicircle is a right angle. So we can see this says RS is 180. So we know that this would be a diameter because that's half of 360. Okay, an angle inscribed in a semicircle is a right angle. So this angle is inscribed. So this is our right angle. The third corollary, the opposite angles of an inscribed quadrilateral are supplementary. So in this picture, every vertex of our quadrilateral is on the circle. So that means it's an inscribed quadrilateral. It says opposite angles are supplementary. That word supplementary means they add up to 180. Okay. Opposite, in this picture, R and T are opposite, so R and T add up to 180, and then U and S are opposite, so S plus U is equal to 180. Practice problems to go along with those. All right, we've got number 1. Given that the measure of angle B is 28 degrees, what is the measure of arc AC? So B is 28. This is an inscribed angle because the vertex is on the circle. We learned that the angle is equal to half the arc when it's inscribed. So we're going to fill in what we know. We know the angle is 28, so it is equal to half of our missing piece of information. So I'm going to call that x. So if 28 is half of x, then I would multiply by 2 on both sides to get rid of this fraction, right? Because these 2's would cancel. And I would get that 56 is equal to x. So this arc is 56 degrees. Okay, the angle is half the arc. Right over here, number 2 says given that the measure of arc AC is 66 degrees, what is the measure of angle B? So this is what I don't know. I'm going to use the same formula. The angle is equal to half the arc. So I fill in that I know. I'm going to call my angle X. That's what I don't know. I fill in what I know, which is the arc, 66. So half of 66 is 33. So my missing piece of information, my angle B, is going to be 33 degrees. Number 3, what is the measure of arc AEB? And this looks like it got cut off a little bit on my copy. So I'm looking at AEB, AEB all the way around. If DB is tangent to circle C, so this is a tangent, and ABD, angle ABD is equal to 32. So this is 32. What is the measure of A? And also my second question, what is the measure of arc AB? So I've got 2 questions to answer here. So our theorem at the top said that if we have a tangent and a chord, that the angle is equal to half the intercepted arc. This is our intercepted arc. I'm going to call that x for right now. I know this angle. The angle is half the arc. Okay, so I know my angle is 32. I don't know what my arc is. So I'm going to solve by multiplying both sides by 2. And I get 64 is x. So this arc here is 64. That answers my second question. The measure of AB is 64. Now the rest of this AEB makes up the rest of the circle. I know that there's 360 degrees in a circle total. So 360 minus the 64 would give me 296 degrees. So the measure of arc AEB is going to be 296 degrees. Okay. Next, we have section 10.5. Oh, sorry, we have a couple more questions for 10.4. All right, section 10.4. Still, we have in the circle below, arc GH is equal to 80. What is the value of x? So we learned that if we have an angle inscribed in a semicircle, this is showing it's a diameter. So this is a semicircle, that inscribed angle is going to be 90 degrees. So that is a 90-degree angle. Okay. We also learned that if we have an inscribed angle, that it's half the arc. Okay, we're going to use those two facts. I know this is half a circle. Half of a circle, because we have 360 total, half of that's 180. So a semicircle is 180. If this much is 80, then this has to be 100. Okay, so x is in this angle here. It's intercepting the 100. When we do inscribed angles, we learn the angle is half the arc. So I don't know the angle, that's my x. It's half of the intercepted arc, half of 100. So x is going to be 50 in this case. Number 5, we have that GH is 70. What is the value of x? So this one, we actually don't even need to know that this is we don't even need to know that that angle was inscribed in a semicircle to do this one. This one, we can just do the angle is equal to half the arc. And so we get the angle is half of 70. So our angle is 35. All right, number 6. The quadrilateral is inscribed in the circle. What is the value of W? We learned that opposite angles of an inscribed quadrilateral are supplementary. Remember, the word supplementary means equals 180. So we need to think which angle is opposite W. The 115 is opposite W, because opposite means their sides aren't touching, right? So the sides of this angle are not touching the sides of this angle. So 115 plus W would equal 180. So if I take the 115 away from both sides, then I get that W is going to equal 65. Next section, we have section 10.5. We have a few theorems we talked about here in 10.5. We talked about when chords intersect, when secants and tangents intersect. Okay, for 10.5, we learned that if we have two chords that are intersecting, that if we need to find one of the angles formed by those chords, we look at the arcs they intersect. We add up those arcs and take half of it, and it'll give us that angle measurement. If we have a secant's the one that goes through the circle, so it's inside and outside the circle, and a tangent, the tangent's the one that just touches the very outside of the circle. Or if we have two secants, or if we have two tangents, we use this formula. You subtract the arcs they intersect. So in these cases, these are the arcs we're looking at. So we subtract the arcs and take half of it to get the angle. Okay. The other thing we learned in this section was about lengths of chords. To get the lengths of intersecting chords, we take the parts of each chord and multiply them together. So if I call this one part 1 and this one part 2, I multiply part 1 times part 2. And then here, if I take this chord and I call this part 1 and part 2, I multiply those together. And your products should be equal to each other then. Okay, so let's do some examples that go along with those theorems. All right, so on your review, the next page, here we have a secant and a secant. So that formula was that the measure of the angle was equal to 1/2 arc minus arc. Okay, so in this case, we've got 130 is this arc, 140 is this arc, and we're solving for this angle. So I'm going to replace those values. M is my angle, equal to 1/2 of 130 minus 40. So M is equal to 1/2 of 90, because I'm following order of operations. So I'm going to do what's inside the parentheses first. So M is equal to 45 degrees. Okay. Then I have a tangent and a tangent. And I'm going to use the same formula because on our notes, we said all three of these cases get the same formula. So we've got two arcs. I've got this arc and I've got this arc, but I don't know this arc. These two arcs together make an entire circle. So the first thing I have to do is figure out what that missing arc is. So I take what I know, the 220, away from 360, I get 140. That's this arc here. Now I can use my formula. My formula was the angle is equal to arc minus arc. So X is equal to 1/2 of 220 minus 140. So X is equal to 1/2 of 80, which would equal 40 degrees. All right, the next one, I've got a secant and a tangent. I'm still using the same formula. This says QR is tangent. It says the measure of arc SR is 96 and the measure of arc PR is 162. What is the measure of PQR? So this is what we don't know, this angle. So I'm going to use the same formula. The angle is equal to 1/2 arc minus arc. So X is equal to 1/2 of 162 minus 96. So if I subtract those, I'm going to have 1/2 of 1/6. Sorry, not 1. I'm going to have 1/2 of 66. So 1/2 of 66 would give me 33 degrees. All right, number 4. Again, we have two secants. So same formula we've been using. We're going to do the angle is equal to 1/2 of 122 minus 58. So I've got 1/2 of 64 is 32 degrees. All right, now the last type of problem that we have that we haven't done yet are the lengths. So we said we multiply the parts together. So I want to look at this chord first. I don't know this length from A to E, so I'm going to call that X. The other part of this chord is 10. So I'm going to say 10 times X has to equal, now I have to take the two parts of my other chord and multiply them together. 5 times 8. So on this side, I have 10x. On this side, I have 40. We divide by 10 and we get x is equal to 4. X represented AE, so you've answered your question.